Arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. Now, if we looked at these numbers right here, now ignore the plus signs for now, but if you imagine they're separated by commas, 5, 8, 11, 14 would define an arithmetic sequence with a first term of 5 and a common difference of 3. Now, what an arithmetic series is, it is still this arithmetic sequence of numbers, except we're going to be adding it up. So maybe we'll want the sum of the first 10 terms or the sum of the first 100 terms. So what we're going to do first is we're going to develop a general formula. Now what I've done here, now we use a capital S and then a lowercase n for the sum of the first n terms. Now in general, the first term is just the a value. We'll be adding to that the next term, term number 2, is a plus d because we add the common difference once. The next term would be a plus 2d because we add the common difference twice, and so on. Now the last two terms will look like a plus n minus 2 times d, and then a plus n minus 1 times d is the final term. That's our general formula for an arithmetic sequence, the final term. Now what I have down here is the exact same thing but written backwards. So starting at a plus n minus 1 times d and then going all the way down to a. Now why I'm doing that you'll see in a moment. What I'm going to do, just like when we use elimination, I'm going to actually add these two equations together. So what I'll actually get here is 2 times the sum of the first n terms is equal to. Now what I'm going to be doing first is I'm going to be adding up, this is my first term in each of the series, I'm going to be adding those up. So a plus n minus 1 times d will give me 2a plus n minus 1 times d. Now doing the same thing for the next set, a plus d plus a plus n minus 2 times d, when I add that up, again, what I will get is 2a plus, now this time d plus n minus 2 times d will give me n minus 1 times d, because I'm adding 1d to n minus 2, so I get n minus 1. Now, if we were to continue doing this on and onwards, we'll essentially just keep getting the same thing. Again, 2a plus n minus 1 times d, and the last one as well will be 2a plus n minus 1 times d. Okay, all of those terms, when matched up, they all add to the same thing, which is 2a plus n minus 1 times d. So what I want to do now, I want to simplify this a little bit, and I want to be able to rearrange the equation or isolate the sum. So here's what I'm going to do. Now the question is first, how many times do I have this term of 2a plus n minus 1 times d? Well, if you think about it, how many terms do we have in the sequence here? This is term 1, this is term 2, and then dot, dot, dot. This is term n minus 1, this is term n. We have n number of terms. So I can simplify this a little bit. So instead of adding this so many times, I can just multiply it by n because that's how many there will be. So my final step to solve for the sum is to simply divide it by 2. And this gives us our first equation, which is the sum of the first n terms is equal to n times 2a plus n minus 1 times d divided by 2. So like I said, that's actually our first equation. It turns out that we can actually make another equation for the sum as well. Now here's what I'm going to do. Instead of writing 2a, I'm going to write that a little bit differently as a plus a. Now why I'm doing that, you'll see in a moment. So a plus n minus 1 times d, and then divide by 2. Now what you may notice, if I highlight this portion right here, well, that looks familiar, doesn't it? A plus n minus 1 times d, that's just our general formula for an arithmetic sequence. So what we can simplify this to is a plus term n, so whatever the final term is plus the first term, and then divide by 2. So these are two different equations that can be used to figure out the sum of an arithmetic series. So we'll take a look at a few examples here. We'll first have to figure out which of these equations we can use, and then we'll solve from there. So the first question we'll look at, we'll find the sum of the first 50 terms of this series right here, 3, minus 5, negative 13, and so on. Now, a series is the addition of all these terms. So what this would actually look like, and it might be written like this sometimes, is 3 plus negative 5 plus negative 13, and so on. So all this means is that we're adding negative values. So let's see what information we can gather from this. Now, just like with an arithmetic sequence, we know that the a value is 3. The d value, the common difference, now to go from 3 to negative 5, we're subtracting 8. And what we also know, we want the sum of the first 50 terms. Now, if you take a look, which of these two equations that we figured out involve the common difference? Not the second one right here. It doesn't use the common difference, but this first equation does. So we can figure out the sum of the first 50 terms by taking 50, multiply it by 2a, so 2 times 3, plus n minus 1, 50 minus 1 times d, negative 8, and then divide by 2. Now you don't have to show me any work in the middle. You can just give me the answer. This would add to 9,650. And there's our answer. Now, it would be possible if you wanted to use the second equation. But what you would have to do is figure out what the final term is. Essentially, you'd have to figure out what term 50 is first as an arithmetic sequence. But that would be adding a bit of work. As you can see, we can solve this in only 2 steps. Now, the next question, find the sum of the first 30 terms of the series with a first term of 15 and last term 189. So again, let's write down information that we know. We know that the first term is 15, and then we know that the last term is 189. So whatever the last number is in the series, it's 189. And there are 30 terms in this series. So this means that term number 30 is 189. So for a question like this, we don't know what the common difference is. We don't really know what happens in between 15 and 189. All we know is the series starts with 15, ends with 189. Now this is where the second equation that we did, this is where it will come in handy, because all you need is n, the first term a, and the final term tn. Now I'm going to add in a note here that tn again represents the final term, just as a reminder. All right, so now we can write this out. We can solve that the sum of the first 30 terms is equal to, so we still multiply by n, but then we do a, 15, plus term 30, 189, divide by 2, and this will give us 3,060. All right, so there's a situation where the second equation would come in handy. Now, again, what you could do using an arithmetic sequence, we've done this before, you can actually solve for what the common difference is. So you could write out an equation like this. And you can solve for d, and then you can plug that into the first equation. But again, that would be adding a lot more work for us. All right, now last question. We want to evaluate the sum of this arithmetic series. But here's the thing, we don't actually know how many terms there are. If you go back and look at both of the equations involve the use of n. We have to know how many terms there are. Well, just remember, we know that this follows an arithmetic sequence as well, these numbers. So the question is, what is the term number for that last term? Well, we can set up an arithmetic sequence. So negative 60 equals, now our a value is negative 5, plus n minus 1, now we don't know what n is, times d. Now you can see from negative 5 to negative 10 to negative 15, the common difference is negative 5. So now we can take this and we can solve for n. So first thing I'll do, I'll add that negative 5, I'll add 5 on the other side. So n minus 1 times negative 5. And I'll divide both sides by negative 5. So n minus 1 is equal to 11, which therefore gives us that n is equal to 12. So now we know that that negative 60 is actually the 12th term in that series. Now at this point, you can use either one of those equations that we use because we know what the final term is and the first term, so the second one could be useful. We also know what the common difference is because we've seen a few terms in the series, so you could use the first one. Now, in a situation like this, I'll typically use the second equation just because it's a lot shorter. So 12 times a is negative 5 plus the last term is negative 60. Now, for proper form, I should actually use square brackets on the outside of this, and then divide by 2. And we get our sum is negative 390. So just remember that an arithmetic series is related to an arithmetic sequence. So you may be able to go back and forth in order to solve for unknown values.